Right, it's perfect.
Okay. Hello, good afternoon. In this session, implementing public warning system. European legislation make it mandatory to deploy efficient public warning system by 2022. What lessons can be learned from countries having already faced these challenges and benefited from such system? To answer this question, we have three speakers this afternoon. terBeek, Director Implementation Services at Everbridge. Sorin, Vasilca, Deputy Director Special Telecommunications Services. And Mathieu Lafforgue, Product Marketing Manager at Intersec. Okay, Peter, the room is yours.
Okay. Thank you. So I'll get started right away because I have an impossible mission to tell you about three implementation in 3 countries in only 15 minutes. We will have a look at the implementation of the National Public Warning System in the Netherlands, which took place roughly between 2008-2012. We will also have a look at the implementation of a National Public Warning System we did in New Zealand around 2017. And I will take a closer look and dive a little bit deeper into the UK implementation, which is about to go live. So it's one of the latest implementations we've done. So starting off with the Netherlands, as I mentioned, they were one of the first countries to implement a national public warning system. We consider them to be one of the pioneers, at least in the EU, for implementing this. And being a pioneer, of course, that comes with specific challenges. So the main challenges we have seen on the NL Alert project, and we deliberately did not put up any technical challenges because implementing a public warning system, of course, it's a technical project, but it also has a lot of other aspects like organization, authorization around it. So the main challenges we ran into on the project in the Netherlands was number 1, the cell broadcast feature availability on the handsets. Cell broadcast is defined, standardized. 3GPP has a technical spec how cell broadcast should be implemented on handsets. But when we implemented in the Netherlands, in fact, the cell broadcast feature was not used for a long time by any mobile carrier for any service. And it turned out that on the handsets that were in the market, a lot of them had not implemented the cell broadcast feature on the handset correctly, or some of them even not at all. So it took the Dutch government a lot of time to bring in the vendors of handsets, to talk to them, to tell them what they needed to implement on their handsets, and to make sure that it was correctly implemented. The funny thing was that all the legacy handsets, so the non-smartphones, they all complied to the standard, but the latest handsets that came onto the market, so especially the smartphones, which became popular at the time, did not fully support the cell broadcast feature on the handset. Another important topic I want to highlight is that when we were about to go live on the system, a discussion popped up about the chain of command, who was actually authorized, legally authorized to send out alert messages to the population in the Netherlands. The model that was implemented in the Netherlands was divided into 25 safety regions, and each region would have their own safety center commander who could authorize to send out a message in its region. But when people started really looking into it, it turned out that only the mayors of a city were by law authorized to send messages out in their municipality. So it also took a lot of back and forth and discussion on that side to agree on an authorization model who could actually send out NL alerts. Again, an example of a non-technical issue that needs to be taken into account when you implement the public warning system. Let's have a look at New Zealand. We implemented the national public warning system in New Zealand in 2017. And for us, this was a huge project, as we provided the complete infrastructure, from the governmental broker up to all the cell broadcast systems in all 3 of the mobile carriers in New Zealand. Timelines were very short. The contract was awarded in June. We started the project early July, and the deadline for sending the first national warning message out, a welcome message, was November 26th. So less than 5 months to deploy 3 cell broadcast systems at 3 mobile carriers and a governmental broker, and integrate all of that together into an end-to-end functioning system. One thing that complicated matters in New Zealand was that they were adhering to the CMAS standard. And according to CMAS, the highest urgency level is a presidential alert. But New Zealand does not have a president, thus they required all the handset vendors to make a change to the cell broadcast client for all the handsets in New Zealand to change the title presidential alert into emergency alert. That may seem like a small thing to fix, but you need to ensure that all the handset vendors make this change, test this change, and roll it out across the country. So when we sent out the first live message in November, only 30% of the handsets at that time received the message, because all the handsets, they needed some turnaround time to be replaced or to be updated over the air. In the meantime, New Zealand is up to the levels of 85% of reach, and it's still going up. We have a yearly test message, and the reach is still increasing. A big challenge for us was, of course, to roll out 3 systems in parallel. Well, actually 6, because each carrier has a geo-redundant system, so a system on 2 sides. So we had to ramp up locally and build a local task project force to make sure that we could do the work, which was for us at the other side of the world, New Zealand. One thing that really helped in New Zealand was that they spent a lot of time and attention to a public warning campaign to educate the people, to tell the people this was coming, to tell them how it would work, that there was no opt-out, that they could not turn it off, when it would be launched. And even at the same day that the first national message was sent, they had a news item on it, on the 6 o'clock news, to announce it. They had the digital displays on all the highways in New Zealand displaying that a national test message would be sent out that day at 6:15. So everyone was aware, everyone knew it was coming, and there were no surprises to people who suddenly received a message and panicked or didn't even know what this was about. Then the third case is the United Kingdom. Although they are not part of the EU anymore, they still introduced a public warning system in line with the timelines mandated by the EU. And we started working on this project in October last year. Also very tight timelines. And for us, the biggest challenge in here was that the governmental broker, so the front-end system that was talking to our system, was not defined yet. It was still under development. We only got a final spec of the interface very late on the project. And the same thing goes for the security requirements, where in the Netherlands and also in New Zealand, the main thing was about reach. How can we reach as many people as we want? In UK, we saw a real shift towards security. Security requirements were loaded on us from all sides. Of course, the mobile operators have their own security requirements. We were deploying at 3 operators at the same time, each having their own security requirements. Then, on top of us, landed the security requirements from the government, first from DPMC, the Directorate for Media and Communication. And then later on in the project, they extended their security requirements when the National Security and Cyber Center was brought into the project. And when we implemented, in the end, all the security requirements, they also came to us that a new telecom bill will be issued in the UK in November, so later this year. So after go live, we will probably need to revise all the security requirements again and have even stricter security requirements. So this is a trend we've seen, security, hardening your systems, making sure nobody has access to the system apart from trusted sources is number one with introducing a public warning system these days. Another big challenge for us was COVID-19. We did not have a local workforce in the UK, so all the work, all the deployment has been done remotely, all via remote access onto the systems. This is the first project I've ever run where we did not meet the customer in person, face to face. No engineers have been on site. My engineers have not been able to work on the systems sitting next to it. Everything has been done remotely. Together with the mobile carriers and the government, we have done a joint post-project implementation evaluation. And I was allowed to share some of the outcome of this. So this is not our evaluation of the project, but this is from all the parties involved in the UK. And three things they've put up, what went well and what they would advise every other country who's going to implement a public warning system. Number one, we need, especially when we cannot get together on site, very close cooperation between all the parties involved, meaning the government, meaning and the National Security Center, meaning all carriers and all suppliers. So the model we implemented here, that there was a shared project environment where all the parties would upload all their documents, share all their documents, unless it was a restricted document specifically for one of the mobile operator. But this really helped in getting everyone on the same information level and keeping everyone on the same information level. There was a very intense project communication structure with daily calls, which of course meant quite some load on my teams, especially on the project managers. But we all agreed in the end this paid off, because with having these daily calls and having these lines open every day, we were able to move fast, even with changing requirements from the government on the interface and from the security teams. Another big contributor to the success of the project was the end-to-end design documents. So all parties sat together to create an overall end-to-end design document. So no separate design just for the governmental broker or for an interface to an operator. There was an interface where all parties and all components of the system were involved. And in the end, that also led to a faster deployment cycle. We had a clear design, we had a clear implementation plan, so that way we were able to implement the systems end-to-end in a relatively short time. And one of the main key factors was the early field test. So from the start of the project, there has been a push towards a field test. The government wanted us to do a field test in March. And they said, no matter how, we want to do an end-to-end test out in the field. We're going to a specific area. We will bring our handsets, and all the operators need to be ready to send out a message. So all the operators, they focused on one technology, 4G. They focused on one node, getting one node of the system live, so not the full redundancy. They called it the MVP, the minimal value platform. And by March, indeed, we were able to send out a message across all the mobile networks to a restricted area successfully. After that, the government again demanded 2 demonstrations of the service. So we did one around the nuclear plant and another one in a populated area around Reading. So the reach and the area was increasing, and also civilians were involved in the last test. So the government was really pushing for an end-to-end test, which also focused everyone on the project to make sure that we could establish an end-to-end service and send out a message within a couple of months.
Peter, 1 minute.
1 minute, okay. What could have been done better? What are the lessons learned, the main lessons learned from this project? Number one, security should be by design. It should be available at start of the project. Any country that is going to implement a public warning system now and is at start, make sure that you have all your security controls defined, that all the suppliers that contribute to your public warning infrastructure have this available from the start of the project. Otherwise, you will never reach the right security level, and it will take a lot more time to do it while the project is already underway. Another one was the device requirements. The first version of the device requirements, so for the handset manufacturers, was created by the UK government, but not by people who knew 3GPP standards, who knew handset manufacturers. So there was a lot of debate and a lot of unclarity and inconsistent information on what the handset manufacturers should implement on their systems. So again, they said if we would need to do it again, we would send our specialists from the mobile carriers to the government, sit down with them, and agree on the handset requirements up front. And the last lesson learned, you can guess this comes from the carriers. The carriers have done a lot of work. They moved mountains, and they were ready in April to launch the service. And we're now in October, and the system's still not launched. So the carriers are really disappointed by that, but the government had some issues in defining when exactly they should launch the service. The first launch was postponed because there was a sudden surge in COVID in the UK, so they decided not to bring this in during the COVID surge. Then we agreed on a date early July, which they skipped because they said we're going to do it after the holiday season. And now we're October, so the latest date we have is October. Technically, the system is ready, but the government needs to announce the service to the public. Because if they don't, the press will do it. That has happened in the UK. The press has announced that the service will be launched in October and that people will start receiving messages.
Okay, I'm sorry, Peter, but
yeah.
Only 4 minutes left then.
Yeah.
Is there any question in the room? I think there is one question on the front. Mister, you ask a question or did you? Oh no, I'm sorry. Okay. Yeah, please. There is here, over here. Thank you.
Thank you. You were talking about the implementation in the UK, that the focus was on cybersecurity. Looking back at the implementations from the Netherlands and New Zealand, what do you would you change in that implementation with the knowledge with the cybersecurity now?
Yeah. Okay. Well, my intention was to start off with the remark that no country is the same, so there's no single recipe for a country to implement a public warning system. Because, for example, in New Zealand, we had to deploy our systems in AWS, so the public cloud. And the government has certified AWS as meeting all of their security requirements. So to us in New Zealand, security was not an issue as it was taken care of by the party that provided us with the infrastructure. For the Netherlands, I think the situation is quite comparable to the UK. So the cell broadcast is running at the operators and a governmental broker in a data center. I think the same thing applies, as I put it in here. The government mandate should be clear. The government requirements should be clear on data privacy, data retention, and security. So the government needs to define what the security requirements are on high level for the public warning system. Not for a cell broadcast center in a mobile network operator, because the mobile network operator will take care of that. But the government needs to define what the security measures are. And I don't...
You have still one question, or if you want, is there any other question, or? Yeah.
Vasilca from Greece. Just I want to ask about the device You mentioned that the device requirements and how the headset requirements must be agreed in front, but from the other side, how you can validate that these requirements will be met in the end. In Greece, we are using SL broadcasting system, but still I receive as the sysadmin many complaints that many devices don't receive the alert.
Yeah. Now, we've also been involved in the implementation in Greece. We were first asked by the Greek government to talk to the mobile handset devices on their behalf, but they did not accept it. They only wanted to change things on the mandate from the government. But in the end, all the handset vendors, they have come to Greece. They have brought their handsets. They have been in the mobile network operator labs, and they have tested their handsets against your requirements. Not that I'm saying that you can't have any handsets in country that do not display the message correctly, because we know that's happening all the time. But usually it is handsets that are not fully supporting the standard, so either imported handsets or parallel imported handsets or legacy handsets. But the main mainstream handsets, like the Samsungs, Apples, no matter if it's Android or iOS, they should follow the standard. So there should not be any handset issues on that.
Okay. Peter, I'm sorry, but now your time is out. I invite people to ask you questions during the coffee break, maybe later.
Okay.
Thank
and
you.
I'm available at the Everbridge stand today and tomorrow to answer any other question. Thank you.
Okay, so next. It's a really tough role because I am the bad cop here. So next presentation, Sorin, please.
Good afternoon, ladies and gentlemen. My name is Sorin Vasilca. I represent the Special Telecommunications Service, for short TSTS, that is provider of ICT services to Romanian authorities. Thank you. We provide ICT services for Romanian authorities, and since 2004 we are the administrator of 112 system, and since 2018 we are the technical administrator of the PWS system cell broadcast. In my presentation, I will present to you the inception of the project and slides, the final slides with how we use it, what sort of messages we deliver to notify the citizens, subscribers of the public networks. And I have the last slide with a final remark. So we faced in Sunday of September on 17th a very strong wind. It was qualified by the meteorological agency as being a tornado, a very rare phenomenon in Romania. And in 10-15 minutes we had 8 deaths and more than 145 injured persons, many houses destroyed in 3 counties of Romania. I remember that date, immediately after the tornado, the Prime Minister called me and asked me is there any technology to be implemented in Romania to notify in time the people. And I said yes, it is the cell broadcast. We had a very, very long process of discussion back and forth around this subject. And that was the moment when the Prime Minister, recently appointed at that time, decided that the next day we have a meeting and to prepare the costs estimates and to prepare the implementation plan estimate. And he called in his office not only the STS, the Authority of ICT Services, but also the National Regulator Agency, the ANCOM, or for mobile operator, and also the representative of Ministry of Interior, firefighters, and Department for Emergency Situation. And in the same day, on 18th of September, we started to work to make the inventory of standards, to work on there were many subgroups that works on the standards evaluation, on the architecture, on the acquisition, documentation. And from these two configuration, based on discussion with our public mobile operator, we decided to implement that is in the top of the slide, because no one had that element called CBC, Cell Broadcast Center, in their own network. So the acquisition consisted actually in the CBE, Cell Broadcast Entity, plus CBS. That is the list just for you to find the list of relevant standards, technical specifications, and mark in bold the mandatory one. And this is the configuration of the architecture. This is what we contracted. High availability and redundant connection in between the CBE and CBS. And the system was designed to be able to connect where the licenses are in around 300,000 network elements. So you could see that actually we purchased the consoles for the firefighters, and then the servers of the CBE in geo-redundancy configuration, two connections toward the CBC, sorry, and a lot of connection to the second generation, third generation, fourth generation of the mobile operators' network elements. The system is very simple in terms of the interfaces used by the firefighters, that has the right, and only they have the right to make the public warning notification. And they have an interface with very clear fields where they put how many times they repeat the message, what is duration in between the repetition of the text itself, and then the area to be alerted. It is a polyline or polygon that is marked by the firefighters, and then the CBC is transforming this area, this geofence, let's say, into the cells of the operator, and then push forward the message to all the stations that are working and gives service area in that location. In terms of security aspects, we needed to separate the STS from the MOI, from the mobile operator, with DMS zones, with firewalls. And we insisted to create the VPN, secured VPN, and each and every officer to have its own digital certificate to ensure the authentication, authorization, and the non-repudiation of the message. Because the system is really powerful, it has the benefits of alerting at a glance maybe 1 million of subscribers, but in the same time we have to trace who inserted that message in that alert, otherwise we could create panic. And there are some articles in newspaper about the false alarm. So insisted to issue tokens with the encrypted certification for each and every officer that touch the consoles of the system. And also we log all the messages for post-processing. All the equipment is is taken into supervision and continuous monitoring in terms of functionality in the Network Operations Center and also in the Security Operation Center operated by our CERT team. About the terminal, it's true the market of the terminal is fragmented. There are many producers, and the main benefit of the cell broadcast system is that the end user or the consumer has to do nothing. The phone is ringing once he is in a dangerous zone where something is going to happen in that zone. The user has the possibility to opt out once he purchases the terminal. If they don't want to get this alert system that is very strong and appears on the screen of the terminals, they have the possibility to cancel it by opting out. But it is their decision for that. They won't be alerted anymore. We had discussions with many iterations and many discussions with the manufacturer, with the retail chain distributors and wholesale distributor of the terminals. And you could see the Emergency Ordinance 46 that forbidden to terminals that are not compliant with the cell broadcast technology. And we let, during negotiation with its manufacturer, because they already purchased and they have in their warehouses terminal not compatible with the cell broadcast, we let them 6 months to sell the products. And since January 2019, no terminal is allowed to be sold in Romania, in the market. This is a matrix, just for you to see that the longest process actually is not the technical implementation, the connection, the installation of the service in that data centers. And it is not our relation or the operator relation with the MOI and with the public operator, because we signed some non-disclosure agreement with them, because actually they give to us their database of infrastructure elements, and we signed with each of the 4 operators such an NDA. But the longest process was to issue the law. It took about 3 years. So the first step was to define one ordinance with that sets the limits or the mark of the responsibility of the STS, of the Ministry of the Interior. And then the Ordinance 46 that refers to the selling of the cellular phones on the market. But the final approval in the Parliament was after 3 years. The system is really useful. It is used by the firefighter, the authority that could alert the people in cases of fires, cases of toxic and explosion or blast of and the presence of toxic smokes. And the message in this case is to close the windows and to get inside in the proximity of such clouds of toxic cloud. What else? The flooding, flash flooding, or freezing rain, when the people is notified about the danger for falling trees, or to evacuate a zone, to run on the hill in cases of flooding. And we use it many times, you see in the statistics, to notify the people about the presence or the aggression of wild animals. We have a lot of bears in the Carpathian Mountains, and they get down in the houses and farms of the people. And once such a bear is detected, his presence is detected, we notify it by cell broadcast system. We use it also for pandemic, during pandemic, just to inform the people that one town, one city, one village switched from yellow to orange and to red, based on the multiplication of the infection. These are the figures. You could see that the last one is more than 50%. That is wild animals, messages, and notification. And apart from this cell broadcast, I consider that it's interesting for you to know that we take into consideration all the system or all other technology that could reach the ear or the eyes of the people. In this situation, it is one application called the application DSU, that is from the acronym from Department for Emergency Situation. The user shall install the application and then mark the zone where he is or she is. And there are some pros for this to use this application, because the user could update information to the authorities about what happened in the scene of the zone, information or movies about the fires, about the flooding, and so on. So it's good for the decision-making process. It's not only unidirectional, but people could load their own records. And also it's good for informing people about the rules, how to act in cases of earthquake, in cases of flooding, in cases of toxic smoke, to inform kids how to protect themselves in cases of such bad events.
Sorin? Sorry.
Yes.
Sorin? Yeah,
Yes,
you have to conclude now.
Yes,
please.
I will conclude immediately. So the next one, it is the tower of the STS, 200 meter, and we built on it a matrix where we could have a scrolling text. And for instance, during pandemic, we recommended to stay at home. It is visible from few kilometers in the clear nights. And its purpose is to inform people about the shelters, medical supply, food, and water in cases of large magnitude events in Bucharest, with no need for other means of communication.
Okay. I'm sorry,
and this is
the last one. Okay.
Yes,
because
this
you
is
are
the
losing
last
your
one.
time.
It is an early warning
Thank you.
system. I don't know if in case of earthquake, it's not for interest for each and everybody of you. Maybe you are outside of earthquake risk zone. I let it here just for you to know that we could alert with 20-30 seconds before the shake, the seismic shake. And by this, we could stop the industrial processes, hazardous processes. Yes, that
Thank
is
you.
the last slide.
Thank you very much.
Yes, you're welcome.
Is there any question, please? Yeah, there is one. Thank you.
Yes, please.
You were talking about the alert messages for the wild animals. How big or small is the area you alert people in? Because in my mind, it's quite a big area, and the wild animal is just...
Yes, there are many such wild animals, but the alert is given under one cell or two cells, just in the village or near the houses of the people where such an animal had been detected. Because the attack is not synchronized, so we don't correlate the events. Once one bear is observed in one town, that town is alerted about the presence on the streets of the bear. There are many alerts, but more of them are local, 1, 2, 3 cells, and that is.
Thank you. Is there another question here? The last one, unfortunately, but.
With all of the operators in Romania not having cell broadcast at the beginning, you decided to have a central cell broadcast center. Did not having to make that investment convince the operators to share their network node information with you? Was it easy to get them to share that information?
Yes, I had a slide. There are two main configurations, and they said that the fastest process is not for them to activate the CBS, their own servers of CBS in their network, but to have one dedicated one, and they allowed us to connect to their infrastructure elements. It was more about the time of implementation. It was faster like this.
Okay, so I propose to go to the next speaker.
Thank you.
Thank you. Thank you very much, Sorin, and sorry for. So again, if you want to ask more questions, I invite you to. Okay, thank you. So now it's Mathieu Lafforgue.
Good evening, everyone. I'm very pleased to be here and honored. I'm working at Intersec as responsible of the public safety product line, and at Intersec we deliver crisis management solution in the frame of public warning system for states, regional entities and municipalities, as well as a mobile carrier solution for alerting as a cell broadcast center and location-based system. So today I'd like to share with you some of our experience regarding the frame of architecture tendering processes in implementing public warning services in Europe and in the rest of the world. So when you implement a public warning system, or when you want to extend an existing one, swap an existing one, refresh, revamp, you can have a shopping list in front of you on public authority side, and you have lots of elements to pick. So today, I will focus on some of them only. Crisis management system, public authorities, and MNO layers in the continuity of Ms. Sorin that has presented before. But the shopping list is quite extensive, and for each of them, you can decide to centralize your solution or to decentralize either on your processes. So let's go through various steps. First of them are about the context on which you define your evolution plan regarding public warning system, distribution of power and perspective objective you decide, and then the consequences regarding the technical architecture option and the tendering processes. And at last, some few words about maybe reassess the whole stuff. So first, it's normally a context, but you can push your stakeholder to make evolution in the law. After, it depends if it's at law level or at constitution level. It's how much are your alert issuers and the power of issuing an alert to the population centralized in your country. So two typical and extreme model, the very centralized one, or where, for instance, only one public authority is entitled to communicate and to issue alert to the population on the left, and on the right, where you have several levels of alert issuer at national level, regional level, province level, and maybe municipalities or firefighter level locally. It depends on your country. It's, as I said, much of a context, but you can try to move the line to maybe organize a process and the program in the country to have a common understanding and a common definition of public warning system in your country. But as I said, for instance, if you take Germany, the federal central state is defined and entitled for defense alerting, as well as aside them, landers are responsible for alerting on disaster and day-to-day activities. So for sure in Germany, you have several layers of alert issuers. So that's the first context to take in mind and to try maybe to push a line. If your stakeholder can, if you're president of your country, you can move the line easier. Second point, what's your objective in the public warning implementation, first one or evolution? Where are you starting from? Maybe you have already a system. Where do you want to go? And where do you want to go for today or the day after? According for European members country, the EU mandate. Externally, you can define your own pace. And where do you want to go in few years, in 1 year, 2 years, few years? Considering that you can have very short term to match maybe the regulation in Europe, European country, or you want to increase the effectiveness of your public warning system, or you want to rationalize maybe old former system. So depending on your objective, you will make a choice of centralization, of decentralization. It will help you to define your paper. And as my co-speaker told before, this part is really important to try to go fast, because defining the plan, it takes generally a long time on the public authority side, and just after the implementation can go really smoother. So, sorry, it's a bit technical. I have a laser saber, yeah, for that. Perfect, thanks to EENA staff. Centralized or decentralized technical architecture. So the two typical model, extreme model, of course in between you can manage some more adapted and suited architecture. If there is only one centralized alert issuer, it will be easier to go on the left part of the slide. And you will have only one crisis manager system at the state level, for instance. And you have also the opportunity, as Romania has done, to centralize even the cell broadcast center if you select cell broadcast as the main alert channel, but you can add also location-based SMS, social networks, publication on website, mobile apps, etc. But you can choose if you're one sole public entities to centralize even the technical part, which income generally to MNOs. The opposite, you push the line on the left and on the right. So when you have several alert issuers in your country, several layers, maybe each layer will want to have its own crisis management system designed and tailored for a particular needs, short-term, long-term, again. The need of municipalities for alert issuing, for communication to people, to citizens, are already different from the communication need at the state level. So sometimes they would like to procure by themselves a system that perfectly suits their need. And same, the MNO layer can be delegated to the specialist of such affair, the mobile carriers, which are generally used to extend and to set up system within the mobile network. There is one point of centralization we saw generally in the middle, even if you're totally decentralized on public authority side, on a MNO layer, it's better to have something in the middle to concentrate to ease integration. We call them alert aggregator, mediation layer, typically something we see in United States of America, or even North America. In Canada, it's the same. In France, the same. In Germany, you need something managed by one public authorities to ease the integration and to have this kind of aggregator for several alert sources and to dispatch them on this slide to MNOs, but on other channels, social media, as I said, mobile application, TV, all the legacy channel of communication. So after technical architecture, just the interest, maybe a bit in details if I have time. Yes, still. Centralized. Generally, as I said, you issue this schema if the political and administrative context is really clear, really straightforward. If you have one actor at public authority side, it's easy. There is a prerequisite, the availability of skills, especially of MNO aspects. So I take really the example of Romania because it's really special, and I told Sorin about that just before this stage. When you have pro at state level, yeah, you can do it. Either you can rely on managed services and consultants, but really it's important to have professional expert of mobile communication, of onset at state level. Peter told you about that as well, and I lay the stress on that. Availability of skills to do that. Interest is to speed the implementation processes, of course, even if implementation can go fast, even in decentralized architecture. The responsibility are clear, very clear. State is responsible for everything. Implementation, design, specs, there is one sole actor, so very clear. One point to be discussed, arranged by law, by negotiation, is the extraction of sensitive data, potentially, from mobile carrier, like the cellular topography. It was one question before. Second one, if you do location-based SMS, is do you extract the localization of people from MNOs and to centralize on the state, the location? And we are not talking here about low full interception, we are talking about alerting. So sometimes, depending on your regulation, the sensitiveness of the topic, it's better to let this kind of the data on MNO layer, this case of which has been chosen in France, to let the statistic and the localization of people within MNO premises in terms of security. So that's the implication of this model. Very interesting, very consolidated, but it doesn't fit all the situation. Decentralized architecture now, as I said, better to have an alert aggregator. You have to define the interfaces between all the equipment, the municipal one, the national one. It's good to define and to rely on standards, actually, most possible use of the standard. The interest is you build and you design at the full, at country size wide, an architecture which is totally resilient, scalable. You can add channel easily. You can add new alert issuer, weather system, etc., etc. You empower all involved party. The choice are made at the place where the skills are generally located. Inconvenient drawbacks, upfront phases, it can last more time because you have to negotiate, you have to make evolution of the regulation, to define service agreement. So it takes a bit more time. In terms of project management, it's not project, it's program management, definitively, but in all cases, you need a program management with tight involvement of all parties, even in the centralized architecture, and the responsibilities are more balanced. So now, I draw, sorry, it was a bit technical, two typical architecture pros and cons. Now I'm moving to what's the tendering process. Of course, there is a one-to-one mapping between architecture and tendering process, but not obviously. If everything is centralized, if the MNO specific system is deployed at the state level, okay, you do one tender. Even in the early stages, you do one RFI for everything. You have the price and definition of what is possible, what's available on the market, state of the art. And after, you can go to a single process. Interest, really fast-speeding process. You have only one. You can optimize upfront, at least upfront, the first cost of implementation. After, on the long run, it can be very different. The opposite system is not totally opposite, but you can delegate to MNOs to choose their own system. They are used to, they have a large purchase team. I know them. They are used to emit tender, to define requirements based on the regulation, based on the service agreement requested by the state, the standard involved. And in this case, everyone will seek for the optimum. So public authorities layers will seek for the best optimal in terms of functionalities, effectiveness, reach, systems that suits the end user needs, expectation. And the MNOs will choose the best solution to fit in their network according to their core network, RAN network, vendors, the integration. Maybe they will mutualize the investment with other use cases. So everyone is playing on its own footprint and playground, I would say. It results generally this model something more standard, agile, and scalable system, full ecosystem. which make quite interesting to delegate. But it takes a bit more time, and it's not centralized by design. There is a little option on the slide. This part, public authorities layer, from what we saw, generally there is one tender, even if MNOs are delegated for their own part. But on public authority side, sometimes the state will want to choose the best solution for the website to publish alert, best solution for him compared to his local context for the mobile application. And so at public authority layers can occur several tenders or with several lots that can be allocated to different vendors. On the left, you select one vendor for all, so it's a turnkey solution. Responsibility are very clear. The project program management is a bit simplified. On the right model, it allows you to select what you design the most according to your short-term, again, long-term objectives and the local context in terms of organization of the state.
1 minute, less than 1 minute.
Yeah. So how to validate the architecture, centralization, decentralization, how to validate the process? I share with you, I like, in fact, these 3 questions from McKinsey. It's derived from dilemma of public standard business question dilemma in enterprises, but it fits well the case here, I found. So first, is it mandated to centralize by law? Your mandate does not say so, but maybe in your country, it's mandated that there is only one alert issuer, and so on and so forth, you will centralize a lot. Does it bring significant value to centralize at state level in terms of program management? Yes. In terms of cost? In terms of feature? Not so sure. So you, again, what is your short-term objective and long-term objective? Maybe it's increase the reach of alert system, the adoption by the population, and third question, or the risk law to manage at state level everything. It's about skills, it's about the time you have. Yeah, so it's an open choice. And to conclude today's presentation, as everyone said, there is no one-fit-all model, so clearly it's about contingency factors in your country. You have to decide on your footprint, either you are state level, regional level, municipality level. You have to ask this question: what are your objectives? Short term, long term. Again, don't think only short term. I know it's important to comply and to check the box, but it's important for the sake of the population, the effectiveness of public warning, and to build truthful relationship with population to take into consideration long-term objectives on the long run.
Okay, thank you,
Thanks.
Matt. Is there any question? Yes, no, I cannot see, it's a bit, yes, please. It will be one question only because we are running out of time.
Hi. The EU directive stipulates that the solutions must work for inbound roamers as well as for citizens of the country where the system is deployed. If you're using a targeted SMS system, you have to track the locations of foreign citizens. And if you're using cell broadcast, you have the issues with the handsets. Again, you can mandate for your own supplied handsets in your own country that they must support the cell broadcast service, but you can't guarantee that for inbound roamers. So can anyone meet the EU's directive on this?
Yes, you have to try. It's true there is a challenge for both technology, so there's the interest of having both sometimes, depending on the type of the alert. Regarding cell broadcast compatibility, it was quite difficult the last 10 years, but things are moving with Apple and Android. It's easy for the brand new phone, once system is defined in a country, that the particular configuration of one country is available in all OS over the world. So when a roamer comes in the country, the handset recognized that is in Germany, for instance, and it applies automatically the local cell broadcast parameters. So things are going to improve, but it's sure that depending on the country, 30, 20%, 10% of the mobile handset won't receive the cell broadcast, and especially in a roaming situation. Regarding the location-based approach, yes, for using that, you have to collect either localization of inbound roamers. Technology speaking, there is no big deal for that. I would say that for lawful interception, state have to, and MNOs too, so just the continuity for use case, which is public alerting.
Okay. Thank you. Thank you, Mathieu. And thank you to our
So if you want to
speakers.
come, we are at booth 29, and tonight at the network cocktail event, we are organizing a little wine tasting. If you want to come, you're more than welcome. Thanks a lot.
Thank you. So I am now in charge of the transition for the next session. So here in 2-3 minutes, you will have a session on improving public safety with smart cities and Internet of Things. In room Alpha, you will have a presentation on user experience and user interface. And in the room Beta, they will focus on emergency apps. So please enjoy, and I hope you will be able to meet and share again with our speakers. Thank you very much.